Okay, let's continue our video. So this is the third part of the video about modular congruence. So before this video, we just have a remark about the pattern of some powers. Okay. Now let's just do another example. Okay, and let me show you why we have to observe the pattern, because otherwise you couldn't solve the problem, because some numbers are just too big. Okay, so for example, we find the remainder when 7 to the power 6, and then remember, not remember, but so be careful. So this is a very big number. So you raise 7 to some power, and what power? The power is 6 to the power 30. Okay, so that means you first evaluate 6 to the power 30, you get a number. Okay, and then you use that number as the power for 7. So this is the meaning for this number. Now when this number is divided by 10, now find the remainder. Now how can you do that? It's a very big number, right? Now here is the solution. Okay, now from the previous example, or from the remark, okay, we know that, okay, we observed the pattern already. So 7 to some power 4n plus 1, 4n plus 2, 4n plus 3, 4n plus 4, and so on. We all have the congruence relation. Okay, so that means, okay, as long as we know the power of 7, whether it's a multiple of 4, or whether that power is in the form of like 4n plus 1, 4n plus 2, 4n plus 3, or 4n plus 4, or whatever. If you know the exact form of the index of 7, then you will get the congruence. Okay, now from the remark, okay, that means it is enough to know whether now this number 6 to the power 30, okay, is in the form 4m or 4m plus 1 or 4m plus 2, or even 4m plus 3. Okay, so once you know whether, so actually there is only 4 cases, right? 4m, 4m plus 1, 4m plus 2, or 4m plus 3. No other choice, okay? Because for a number is either divisible by 4, or after you divide that by 4, you have a remainder 1, or remainder 2, or remainder 3. So once you know the exact form of this number 6 to the power 30, then you know what should be this 7 to the power 6 to the power 30, because you can check this cycle. Anyway, so we have this, and so we need to find the number r, for example, number r such that 6 to the power 30 is congruent to r modulo 4. Now you see, you have another problem there. Okay, originally you have to solve the problem modulo 10. Okay, but now because you want to know the form of the index, and in order to know the form, actually you have to take the congruence modulo 4. So you change the problem. I mean, you have another congruence problem, so you cannot solve it in one step. I just want to say, okay. In fact, because you want to know the index exactly, whether it's a whether it is divisible by 4 or not. So that's why you have to take another congruence. But this time, not congruence 10, but congruence 4. Okay. And of course, this R satisfy this 0 less than or equal to R, but less than 4. Okay. So once you know that, you solve the problem. Now, okay, now, oh, sorry. Now we have 6 congruence to 2. This is the first step. You take the congruence 4. 6 must be congruent to 2, right? Because 6 minus 2 is just equal to 4. Okay, so you can take power. Okay, so 6 to the power 2, that is 36. But this is also equal congruence to 0, right? Because 36 is already a multiple of 4. So you got this. Okay, so 6 to the power 2 already give you 0. Okay, so that means, so hence, if you have 6 to any power, okay, any power n, for example, so it must give you 0 after you take the congruence 4 if n is bigger than 1. Okay, of course n equal to 1 is not true, but when n is equal to 2, for example, because n equal to n bigger than 1, if n equal to 2, 6 to the power 2, that is 36. That will give you congruence 0 modulo 4. So hence, and we have 6, in particular 6 to the power 30. 30 is very big already, so of course it's bigger than 1. So 6 to the power 30, it must be congruent to 0 modulo 4. So you got this. That means, what is the meaning? So hence, in other words, I should say, okay, in other words, we have 6 to the power 30, that is equal to 4m for some m, integer m, I mean. Okay. Therefore 7 to the power this number, okay, that is a huge number, as I said. It nothing but just like this 7 to the power 4m. Okay, once you know that, now it's very trivial, and you know 7 to the power 4m always give you 1. Okay, modulo 10. So the remainder is what? It's 1. Okay, and you solve the problem. Okay. Now before the end for this video, okay, so let me just give you another remark. So why do we have? Why I keep doing problem module 10? Okay, so that's a reason. Okay, if you can make the observation, that would be very good. In fact, if you notice that the remainder, okay, of the above examples, so taking module 10, okay, always give you what? Give us the unit digit of the original number, okay. So in other words, okay, now of course you know how to find the remainder, but if you think in another way, okay, hence, okay, to find, for example, to find the unit digit, okay, if you want to find the unit digit, then what should you do? In fact, you just have to do what? Take the division, okay, by 10, or if you don't like taking the division, then you can simply do the congruence modulo 10 for a given number. Okay, so in order to find the unit digit for a given number, okay, say n, okay, it is equivalent to find, okay, to find R such that n congruence to R modulo 10 with this, okay, with 0 less than or equal to R, okay, but less than 10. Okay, once you can do that, then you can get the remainder. Of course, you get the remainder, but the remainder also tells you the unit digit of the number. Okay, that is more important because sometimes we just want to know the unit digit for some numbers. Okay, we don't really want to know the exact value for the number. Okay, for some reason. Okay. Now, how can you get the unit digit? Well, just by using this method. You just take the congruence, keep taking congruence, reduce the value until you get the number between 0 and 10. Now, if you take the congruence 10, it will show you the unit digit. Now, think about it. Okay, so a very easy question. Okay, if we want to find the 10th digit, okay, the 10th digit, what shall we do? Okay, in fact, we can try, or you can try. Okay, you can try to take congruence. Okay, I should say to take mod 100. Okay, and see what happens. Okay, now actually, if you do that, you will not just get the 10th digit, but you also get unit digit as well. Okay, you can try it. Okay, and if you have question, you can let me know, and I will show you more examples or explanation why it give you the 10th and unit digit. In fact, I have some other problems, okay, that can show you, well, it must give you the unit digit and the 10th digit as well. But try to think about it. Okay, why? Okay,